Alright, in this video we're going to tackle some problems with sets and subsets. So, for our first question, we have a set B containing the elements 2, the set containing 2, and the set containing 3. We have 8 statements here, and we want to know which ones are true. So the first one, 2 is an element of B. Is that true? Well, yes it is. We can see 2 is right there. So we can say yes. Is the set containing 2 an element of B? Well, when we look at our elements, we see the set containing 2 in our set B. So the answer is yes. The set containing 2 is an element of B. Now we have the question, is the set containing 2 a subset of B? So we remember the definition of subset. If we have an element in our set A, then it must be in the set B. So, is 2 in the set B? And the answer is yes. So the set containing 2 is a subset of B. So the next question is the set containing the set 2 a subset of B? So we ask ourselves, is this set containing 2 an element of B? And we knew from before that yes it is. So the set containing the set 2 is a subset of B. Okay. Next question, is the set containing 3 an element of B? Well, let's take a look here. We see the set containing 3 is an element of B, so the answer is yes. Is the set containing 3 a subset of B? Well, 3 has to be in B. Do we see 3 in B? No, 3 is not in B. The set containing 3 is in B, but not just the element 3. So the answer is no. The set containing 3 is not a subset of B because 3 is not in B. Okay. Is the set containing the set 3 a subset of B? Well, we need to see if the set containing 3 is an element of B, and the answer is yes. So, of course, this is going to be yes. It is a subset of B. And is the set containing the set 3 a proper subset of B? So this means that the set containing 3 is in B, but B has more. So the answer is yes, B does have more. So this is a proper subset of B. Okay, that was the first question. You may see this on an exam, probably not, but to get a good understanding of sets and subsets and elements, this is a pretty good exercise. So question 2, we're given a set in set builder notation, and we're told to list all the elements inside of it. So, for the first one here, we have the set containing 1 plus negative 1 raised to the n for all natural numbers n. So we can check some things out here. We can say, okay, if n is equal to 1, then we have 1 plus negative 1 to the 1, which is equal to 1 plus negative 1, which is 0. So we know that 0 is going to be in this set. If n is equal to 2, then we have 1 plus negative 1 squared, which is 1 plus 1, which is 2. So 2 is going to be in the set. Okay, now we can check n is equal to 3. This would be 1 plus negative 1 cubed, which is just 1 minus 1, which is 0. So we already have 0 in the set, and we can see that this pattern is just going to keep repeating. So this set, 1 plus negative 1 raised to the n for all natural numbers, is just the same thing as the set containing 0 and 2. So when we talk about efficiency when writing sets, maybe this notation here is not a good idea when really we only have to list 2 elements. So consider that when making your sets. This next one, we have the set of n squared plus n cubed, where n is in 1, 2, and 3. So we just need to check 3 values here. We need to check n is equal to 1, n is equal to 2, and n is equal to 3, and then their results are going to be in the set here. So n squared plus n cubed. That means that 1 squared plus 1 cubed, and that is 2. So 2 is going to be in the set. We have 2 squared plus 2 cubed. That is a little bit of a mess. Let me rewrite that. That is 2 squared plus 2 cubed, which is going to be 4 plus 8, which is 12. So 12 will be in the set. And then we have n is equal to 3, so that's 3 squared plus 3 cubed, which is just equal to 9 plus 27, which is 36. So 36 will be in the set. Okay, so those were the elements of two sets in set builder notation. You should be able to go back and forth between these. So if you're given a set with 0 and 2, you should be able to come up with some way of describing that in set builder notation. And if you're given 2, 12, and 16, you should be able to backwards construct something, maybe not as complicated as n squared plus n cubed, but something that will produce the same result in set builder notation. So you should be able to go back and forth if you have to. And that could even be as simple as saying x such that x is in the set containing 2, 12, and 36, which is super cheating, but it's still a set in set builder notation. So, final question, a little bit more challenging. It is a proof type question. Suppose A is a subset of B and B is a subset of C. Prove that A is a subset of C. Okay, so how do we start these? First of all, we suppose A is a subset of B, B is a subset of C, and we want to show that A is a subset of C. So we need to start with something in A. So we're going to start and say, let some element be in A. So let X be in A. Since we have that A is a subset of B, by definition, if X is in A, then X must be in B. So we know that X is in B. So we have then X is in B. And then since we suppose that B is a subset of C, we know that if X is in B, then X has to be in C. So then we know that X is going to be in C. So because we supposed that X is in A and we end up with X in C, we can now claim, using therefore, A is a subset of C. And that's by definition of the subset. So that is how you do a proof of something like this. So anyways, those were some practice problems. If you want more, please let me know in the comments below. If you have any suggestions for questions, put those there. And if you have any questions about these questions, please leave those there as well. And I'll answer them the best that I can. So if you like the video, share it and like it. And I'll see you in the next video.